right, so before we start on pages 11 or 12, I want you to take a second. This is actually in your assignments packet after that, the homeworks. And this is a DIN, but I really would like for you to work on it because it reviews linear versus exponential functions, which at this point you should be able to look at a table, a word problem, or a graph and know if something is linear or exponential and be able to tell me why. So before we start with these notes, I'd really like for you to do that, please. For our notes today, we are going to be on page 11. And you will notice that on page 11, there's something boxed in, and it's the word memorize, because you need to know these two formulas. The reason why you need to know them and you have to memorize them is they are not on the formula sheet. On the formula sheet, there is an exponential growth and decay function that we do not use. It is way too confusing. You're just going to have to memorize these formulas. So if we are an exponential growth function, y equals a, 1 plus r to the x. You're an exponential decay, y equals a, 1 minus r to the x. What are some things you notice about those functions? I'm hoping you said to yourself that they look exactly the same. The only difference is one is plus and one is minus, which you are absolutely correct. They're the same exact thing, except if it's a growth, you're going to add. If it's a decay, you're going to subtract. A is our initial value. It is going to be what we start with. R is the rate, which we do need to go from a percent to a decimal. So you can either move the decimal or you can divide by 100. And the x stands for whatever amount of time has passed. And so what we're going to do today is we're going to use this formula to help us to answer a bunch of questions. And at the end of this, we're going to be 100% confident with calculating exponential growth and decay. So looking at our first example. Josie invested $500 in an account earning 5.25% annual interest. Determine the amount in her account after 18 years. State the values of A, R, and X. Should you use plus or minus? Write the equation and fill in the correct values, and then simplify. So take a second and underline what's important in that problem. So Josie invested $500 in an account, earning 5.25% annual interest. Determine the amount in her account after 18 years. So A is her initial value, starting with 500. The rate is 5.25%. So I can either move the decimal or divide by 100. I'm going to move it 2 places to the left, 0.0525. And X is the time, which is 18 years. So it says she invested $500 in an account earning 5.25% interest. We know interest adds to your value, meaning that this is a growth. So I know I'm going to use my exponential growth function. Just like with the quadratic formula, if we're using the formula, we better be writing it down so they know what we did. So now I'm going to plug it in. Y equals A is 500. 1 plus R is 0.0525 to the X, which is 18. So now this is the only stinky part. If you have a scientific calculator, just be careful. Make sure that when you put this in, you do use the parentheses. And if you have the scientific calculator, you're going to need to make sure that you use the caret button. So the one, let me circle it. The one that looks like this. Right here. The one that looks like that caret button, okay? So now we're gonna just plug that into our calculator. 500. 1 plus 0.0525 caret 18. So now that's a decimal, and I'm talking about money. So I should ask myself, how many decimal places is it for money? It's 2 places, which means I'm going to write down 3 numbers. Y equals 1255.937. The rule for rounding. Find your place, look next door, 5 or higher, add 1 more. 4 or less, let it rest. Okay? So I'm going to find my place. 1, 2. Look next door. 7 is definitely 5 or higher, so that 3 is going to change to a 4. Nothing else is going to change. So the answer to my question, 1,255 and 94 cents. Okay, number 2. The population of a town is decreasing at a rate of 2.5% per year. If the population in the year 2000 was 28,000, what will be the expected population in 2015 if this rate of decrease continues? Something popped up there twice. It's this idea of decreasing and decrease. We know that decreasing and decrease means that we are going down, 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 down. So should I add or subtract? I'm hoping, oh my goodness gracious. Always, always, always. Mind you guys, this is all the same day, every single video. Y equals, you should have said to yourself, decreasing, Miss O, silly goose. So now take a second, go back, underline your important information. Told me my rate, 2.5%. I got a 2,000, 28,000, 2050. Well, crap. I gotta find my starting amount, my rate, my time. There's a lot of numbers up there. The rate is the easy one because the rate is the percent. Okay? 2.5%. Let's turn it into a decimal. Once, twice, 0.025. Okay. So now I have a bunch of numbers left. Let's try to decipher these. So if the population in the year 2000 was 28,000. Okay, so I'm starting in 2000 with 28,000. Okay. I need to find 2015. Well, I know that I can't plug in 2015 because I started with 2000, right? How many years are in between 2015 and 2000? If I want, I can set up the math to get 15, or maybe you saw that right off the bat. Either way, 15. So now I'm going to plug it into the formula. Y equals my starting amount, 28,000, 1 minus my rate, to the 15. am going to plug these into my calculator. $28,000. 1 minus 0.025 to the 15. All right, so I'm talking about a population. Can you have decimals with a population? Your answer should have been no, which means I'm going to write down everything and then one more number. So I'm going to write down up until that 0.5. And then I'm going to find my place, which is the decimal. Look next door. 5 or higher, yes, so I'm going to add one more. After 2 comes 3. So this is actually 1, 2, 3. 19,153. I would love for you on this next page to try these two. Underline your important information, plug it in, pause the video. Okay, the current student population of the Brentwood Center is 2,000. The enrollment at the center increases. Increasing means plus, so I know I'm using the exponential growth. At a rate of 4% each year to the nearest whole number, meaning no decimals. What will be the student population closest to in 3 years? A, R, X. My starting amount, 2,000. My rate, 4%, 4.04 when you move it. My time is 3 years. I don't think we could have got any more straightforward than this question. So y equals 2,000, 1 plus 0.04 to the 3. So when you plug it in, it said to the nearest whole number, meaning you should have wrote down one extra decimal. So out of your calculator, you get 2,249.7. Find your place, look next door, 5 or higher, yep. Add one more, so now we gotta change the whole number. That 49 is gonna change to a 50. Okay. Last one. The value of a car purchased for $20,000 depreciates at a rate of 12% per year. What will be the value of the car after 3 years? Anything about values of car? Also, the word depreciates means you're going down. So I know I'm using the exponential decay formula. Starting amount, 20,000. Rate is 12%. I really hope you didn't fall in that trap, because when you move it once, twice, this is the first one, it's 0.12. There's not a 0. Our time, 3 years. So y equals A, 20,000, 1 minus my rate, 0.12, to the 3. This one's talking about money. When we plug it in, $20,000, 1 minus 0.12 to the 3. I get it to 2 decimal places, so do I have to round this one? Your answer should be no. So 13,629.44 cents. Need to pause video. You should be completing this one. And also, you are in a position where you can work on the Regents Prep exponential functions tomorrow.